Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Bommer, part number BB5006 545N in a 630 finish. So a heavy-duty hinge is what it is. This video is going to serve as a visual review, dimensional review of the item, what it's used for, where you're going to use it. It's one heck of a hinge. You don't really sell the good stuff that often on smaller jobs. And this hinge would be called the good stuff. Why is it the good stuff? A number of reasons. First of all, it's made of solid stainless. Okay. Exterior application. This is going onto the small building. Think of a cell tower where there's a tiny little, whatever it is, 100 square foot shack building. Although it's not a shack, they're made to quite robust standards. Same concept, but going into a municipality's water storage tank is where this is going. Made of stainless steel. It is heavyweight. It's ball bearing. It's 5 inch tall for an 1 3/4 inch thick door, and that means that it's going to be rated for one heck of a heavy door or a wider door. This door is neither heavier nor wide in the sense that it is a typical door. Let me pull up, before I get too much further with what I'm talking about, let me pull it up. Okay, so it's a 3'4" door. So best practice, when you're dealing with a door, while it's just 16 gauge, when you deal with a door that's wider than 3 foot, it really starts to become best practice that you're using a 5 inch hinge, a 3/6 door, a 3/8, a 4/0. It's certainly not going to be a bad idea at all to use a taller hinge because it's so much more capable, something in the tune of 20 or 25% more capable at simply handling the weight of what it's being asked to handle. So in this project, I don't believe that 5 inch was dictated. I think I specified that because it's a 3'4" door. I would think that the village, the taxpayers, don't want to replace this door in 5 years. It'll have very low use, but I would expect it to be incredibly long-lasting. The door that we did is indeed galvanized, so I would think that they'll have really good life expectancy out of the steel frame, the steel door, and at least the hinges that are hanging the door. So let's, and this is what the hinge looks like. Let's dissect the part number a bit, and that will allow us to understand better what we're dealing with. Okay. BB5006. We're going to dissect it. I'm waiting for the catalog to come up is what I'm stammering for. So the BB5006, dissecting the part number left to right. BB stands for ball bearing. You can see that there are 4 bearing packets that are here. This happens to be a heavyweight hinge, so that it will have, so therefore it has 4 bearing packets. I would easily think that this door would be this hinge would be well equipped to handle a 250-pound door. You get into doors that are simply taller than that, or pardon me, heavier than that. The issue is that the top hinge does 70% of the work of carrying the door. So when you get into stuff that's taller, you've got one hinge basically doing all the work. You've got the hinge plates that the hinge is attached to, and those welds all doing the majority of the work to just carry the door. You get into doors that are heavier than that. I don't think that you're going to have a problem with this hinge literally bending under that sort of load of weight. I think the problem is because of how the hinges share the work quite unequally is where you really need to start to get into, let's not use hinges on this, let's go to pivots. Now there are charts that you can find hinges that will hang doors in excess of 300 pounds. The decision really has to be made in terms of what's the best way to take the weight of that door and apply it. Do you want to apply it to the jamb and therefore the majority of work to the top hinge? Or do you want to think about a pivot and apply all of that work to the ground, to earth? Let the earth hold the weight of the entire door. The top pivot does nothing except keep the door from falling out. The intermediate pivots can be load-bearing, or they can just keep the door straight, kind of thing. So when we're talking about a heavyweight 5 inch, we're talking about weight. I've done hinges that are 6 inch tall because the door was very was very heavy. But pivots need to be kept in the back of a specifier's mind in terms of when is it time to move to a pivot. I've also sold people hinges with a lead line door, just a 1/16 of an inch, and that hinge stood no chance to hold the weight of the door. You really need to think about pivots in that scenario. Now, it's a BB, it's a ball bearing. That's literally what it means. The 5 in the part number means it's 5 knuckle. You can use your imagination and see why it's that. The next 0 means it's full mortise. You can see from the swag on the hinge leaf here and here that when the leaves are brought parallel, they're meant to be mortised flush to the edge of the door and frame. The next 0 stands for standard. It's just a regular hinge, a couple of mortised leaves, nothing unusual about it. There is no attribute to the hinge that clearly defines it as an important derivative, such as anchor hinge or raised barrel or through wire, things of that nature. The 6 in the part number, that means a couple of things. It means it's not only heavy weight, the thickness of the leaf, but it's also non-ferrous. Pardon me, it actually means stainless steel. They've got a different part number for brass, heavyweight. This ought to be 190 thousandths thick. That's what a 5-inch hinge is going to measure in terms of thickness when it's heavyweight. And my caliper tells me 0.185, so 185 thousandths thick. The next part of the part number is the size, 545. The height is the first dimension. The Bommer convention to apply sizes to their hinges is quite unique to them, and you definitely want to be sure that you're ordering the right size. 450 is 4.5, 4.5. 454 is 4.5 by 4. I would think 454 may be what I want, 4.5, 4.5. So be mindful to get that cleared. 5 by 4.5 is what this is. So it's 5 inch tall. Really important to understand that the height is the first dimension on such a hinge. It's 4.5 inch wide. Why didn't we use a 5 by 5? Well, a 5 by 5 would be for a door thicker than 1 3/4. And we probably could have used a 4-inch wide hinge. We probably could have done a 540 if that's a, I'm not even sure if that's a good part number. It might be. The point is that we've got a hollow metal frame that is wrapping over CMU wall construction so that the pivot point is sticking already proud of the face of the door. Whether that was going to be a 4.5 inch wide hinge or a 4 inch, the hinge will still permit the door to open up as far as it will go until it's stopped by, you know, a wall or the door closer or some other obstacle. So a 4 inch may have been a good example, a good use for this, a good size to apply on this particular job. But a 5 by 4.5 would be a more standard hinge to get in those two dimensions. I'd like to have the vertical axis of pivoting as close to the face of the jamb as possible because there is, you know, documentation out there that says it carries the weight better, and plus there's less projecting hardware. And while it's only 1/4 of an inch, it really matters, 1/4 of an inch. You don't maybe consciously think about the projecting hardware, but you'll sure indirectly think about it when you're walking down a hallway and you crack the face of your watch on a hinge or that's hanging off the face of the door if you've got a hallway with doors that swing into the hallway. If you're maneuvering around a small space and there's door hinges, keep them tucked back to the face of the door, and it would be considered best practice in that sort of scenario when dealing with a 4.5 inch hinge to make it 4 inch wide. So this is 5 by 4.5. It's also important to know that the height is the first dimension because you're going to tell your manufacturer to prep the door and frame for something. This is 5 by 4.5. When you're having a door manufacturer prep for something, I don't even tell them the width of the hinge. Okay, I tell them prep for 3 5-inch 190 thousandths hinges. Okay, I don't tell them it's 5 by 4.5. I only give them the height. They don't care about the width. The width can be 4 inch, 4.5, 5. It can be 20 inch wide. It doesn't matter to the door manufacturer. And I have seen 20 inch wide throw hinges. It's just it's important to know because it's the opposite of how doors are sized. The width is the first thing on a door. And I think the reason is, why is the first dimension what it is? The correlation I come up with is it's the most important, or the more important of the two to know. So when you're hanging a door, yeah, I want to know how tall the hinge is, because that's going to relate to the capacity that the hinge can handle. If I'm talking about a door, what's more important? Well, the first thing that I'd like to know is how wide is it? Then tell me the height. So don't tell me the height and then the width. The width is what is going to be more defining of a characteristic. And I think the same logic applies to a hinge or to an access panel, where the second dimension is the dimension that the hinge is on. Or a roof hatch, the dimension is where the hinges are, or when you're facing the roof hatch, the width is that first dimension. That's what you want to know as you're coming up the stairs or going down the stairs through a roof hatch. So hard and fast decision as to why the height is the first dimension, it's probably just because it's more important than the also important width dimension. Now this has an N in the part number. On the outside, and this is an exterior door that swings out, you see no evidence of that set screw that I have pointed out earlier, well, pointing out now. That set screw, when that door is closed, you don't see any evidence of it anywhere. What that set screw does is provide the security over the pin. That's the non-removable pin function of this hinge. It's an out-swinging door. It's an exterior door that swings out. You need a security feature on the hinge. N by Bomber is our non-removable pin. The pin has a groove cut in it. That set screw is tightened, and that set screw sets inside of that groove. And believe me, it all but makes impossible the driving of that pin out of the barrel. This is what's called a button tip. We'll talk more about that in a moment. The bottom end has a hole that you can drive that pin out, but you're for sure first going to want to loosen that set screw. It is a very effective means to provide security over the opening in order to prevent the driving of a pin out so that you can just tip the door out and gain access. Then we have 630. That means solid stainless with a brushed finish. Solid stainless with a brush finish does equal the absolute most durable of all finishes. They call it a natural finish. No other finish is more durable than stainless with a brushed finish. Because it's made of stainless, they can also do a polished finish. I have been in retail locations where they've got these really huge doors, and they're polished stainless. It's stainless steel. That can be brushed, or it can be turned into a polish as well. So you can make it look highly reflective. Now, let's step back a little bit on the sizes. Of course, you can get any size really that's necessary for a project. I don't know what the largest they'll go to, and I don't know if I've done 8x8 by Bommer, but I've done 8x8 by other people, so I'm sure it's available by Bommer. The security options, you can do the N for non-removable. You can also do a security stud, and a security stud is going to be basically a feature on the hinge that is about the diameter of a nickel. I'm looking in my catalog. They don't show a picture of it. About the diameter of a nickel and maybe a 1/4 inch thick. There's a hole on the other side so that when the leaves close, that security stud, is sticking through the hole. So even if you were to drive the pin out, well, that's great. You're still not going to separate those leaves. It would be a good approach to do both a security stud and a non-removable pin. I would want to deter both. Maximum security studs are attached to the back of both hinge leaves and project into holes in the hinge reinforcing plates in the door and frame. These studs secure the leaves to the door and frame and are often used in combination with hospital tip hinges in high security areas and institutions. So a maximum security stud is simply a reversed security stud, where that nickel diameter 1/4 inch thick or so features on the back, projects into the prep into the reinforcement for the hinge in the door and into the reinforcement for the frame. That will, of course, very positively prevent you from pulling that material out as well. Okay. Now, let's take a look at the extended description of this item. As we move down into the extended description, it says for heavyweight doors, high frequency. Absolutely. Heavyweight, 5-inch tall. Stainless steel hinge with a stainless steel pin. This is completely non-ferrous. ANSI A5111 is a reference to the document that this is compliant with. This is called template. What that means is the location of the holes would match what we would call the template pattern for a 5-inch hinge. If you are dealing with a template pattern 5-inch hinge, doesn't matter who the manufacturer is, the locations will always be the same, okay, which is really helpful. There is a link below this video to a document called template. Actually, this one's called cut sheet. It's a dimensional drawing of the hinge and will show you where those holes are located for this hinge. You'll see that regardless of the width of the hinge, the holes stay in the same location. The only dimension that changes is the A dimension, which is the outside of the leaf to where the swag begins. So the A dimension from here right up to here. Okay. This one would be 1 13/16. You'll see, so regarding the location of the holes, and speaking of holes, by the way, screws are indeed included. Now this is a hollow metal door, hollow metal frame application, and best practice is to instruct the manufacturer in the part number that you're ordering the fasteners that are to come with the hardware. Okay, so what they've shipped us here are all machine screws and half wood screws. Well, I specified all machine screws. They put some wood screws in there. Okay, they didn't need to. And frankly, I would prefer if they did not, because someone might say, it might be a phone call, what do I do with this screw? Nothing. They shouldn't have sent it. The other thing that I don't like about that occurring is maybe you become dependent on always getting half wood screws when they're not included necessarily, and therefore it could create a problem in the future when you are not in receipt of wood screws when it's clearly a metal door and metal frame application. So always define the screws that you want, because if this was, and it could have been, a wood door and a wood frame, and the screws were not included, it would be highly unusual for you to get 8 wood screws and 8 machine screws, especially in stainless. So that would be why, for sure, you're going to want to specify it. You don't want to get to the job. If you've not checked the hardware, check the hardware before you go. You don't want to get to the job to find out that you are lacking basic material to get the job done. The lower lower left-hand corner, column for steel base, brass or bronze, and then stainless. You can see how the part number changes quickly as you change the base material. That's the first row. The second row, you'll notice that that part number has a 1 in it. You'll notice that only occurs in hinges where they are wider than they are tall. Those are wide throw hinges, and the 1 in the part number literally means we now have a hinge that's what's called a wide throw, where the width is greater than the height. You then have the LB series, same configuration on rows, except that's a 3-knuckle hinge. And that would be concealed bearings. It would be a very good-looking hinge, the 3-knuckle LB 8000 hinge. That would be an LB. If this was a 3-knuckle concealed bearing, this would be an LB 8006 is what it would be. Sometimes looking at all that's a bit busy, and I agree. I think that it is. Having a cleaner knuckle is where you're going to look to your 3-knuckle type hinges. It does absolutely look cleaner on the door. If you are not sure if the hinge screw hole locations match with what you're doing, refer to that document before proceeding. Non-rising removable pin is standard. So what we're saying there is that the standard pin is non-rising. If you've ever noticed a door over time, a door will open and close hundreds, thousands of times. So those pins have a tendency to creep up a little bit. I think of it as the process of extruding, where you're forcing something through something, and with those hinge knuckles going against each other, that pin just kind of gets squished and pushed out towards the top. A non-rising pin will have some knurling done on the top of the pin, so that when you seat it down, it is going to be quite, it will be most certainly not disposed to creeping up out of the top of the hinge. It's for me, it's a downfall of a lot of high-end residential decorative hardware manufacturers who make hinges. I think their hinge design is inherently deficient, because you will constantly have a pin problem on these expensive hinges that are very beautiful. With the screw-in decorative tips, the pins inside of there still move. The threaded-on tip still comes loose with time. It will fall off the bottom. Now your pin's going to start to move. So the residential people could take a study of what commercial people do to keep those pins from hopping out on you over time. Button tip and plug. So that's your button tip. If you use your imagination, it looks like the button on your coat. That's your plug. That's what will allow you to drive that pin out. If for some reason you wanted to do that and reverse that pin over, you could, but there would be no reason to do it. This hinge is going to work on either hand door. 190 thousandths. The screws, the machine screws are 12/24, and the wood screws are 12 1.25 inch long. It does have 8 holes. Decorative tips can be done. You can do a decorative tip on this. The most common decorative tip is ball tip. You can do an urn, a steeple, an acorn tip. I don't know if Bommer does an acorn. They don't. They do. They don't list the urn tip. Speaking of tips, they can do hospital tips, where they will take this and they will heavily radius this entire corner of the hinge here and up here. And what that does is it will prevent something from being hung on the top of this hinge. That would be a ligature resistant feature. It would be a safety feature, so that someone could not hang something on the hinge like a belt or a shoelace and cause harm, is what a hospital tip would be specified for. Pin options, stainless steel or brass. This is going to have a stainless pin. And the security options we discussed, round corners, you could, and I have, order this as a radiused corner. You know, if you wanted a really epic hinge that was for a large wood door you were doing, and you wanted solid stainless, you wanted heavy weight, maybe you wanted 3 knuckle, but you wanted 5/8 radius, that can be done. Maybe put acorn tips on here as well. Okay. That sums up everything, with the exception of you will get some cardboard shims in the box. Not many people do it. Bommer is among one other company that I can think of that will send some cardboard shims. Be mindful you're not to use, it's not permissible to use cardboard shims on fire-rated doors at all. If you're going to use shims, which you can, they must be made of steel, so long as your door doesn't exceed the margins specified by the governing documents. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the Bommer products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Any questions on the Bommer BB5006 545N in a 630 finish, or any other Bommer product, please feel free to reach out to us. And thank you.